Okay, we're going to look at just some three-dimensional trig. Okay, so first of all, let's just look at the question. So a tower CD, so this is our tower CD, and we're going to have C is at the, I'm going to put C at the bottom and D at the top. So that should be A and B. CD is 15 metres. Okay, now the angle of elevation of the top of the tower is 40 degrees, and that's from A. So I'm going to make that 40. I'm not sure where A and B are yet, so I probably need to do, if we look at this here, we'll just be careful, but it's going to be 40, and A, the bearing, and 55 degrees from B, okay? Now, this part here about the bearing is what will tell you where they are positioned. So if you go onto the thing and you make this the tower, I'll make this C at the bottom. I'm just going to do the bearing part. So you need to do that separately. The bearing of A, so A is on a bearing of 120 degrees from the tower. So 120 is here. And then it says that B is on a bearing of 210 from the tower. So 210 comes all the way around to there. So that angle on the ground there, 210, so this is A and this is B, 210 minus 120, what would that be? So you go 210 minus 120 and you end up with 90. So if this is A and this is B, then ACB would be, that's 90 in there. Okay, so that means the elevation from A is, of the tower is 40, and it's 55 from B. Okay, so the next step now is we want to find the length of AB. So we want to find that. So in order to find AB, what we need to do first of all is find BC, and then we need to find AC. Okay, so in order to find BC, let's put Y there and Z there. Okay, so for BC, if you look at these triangles here, and you redrew that triangle out there, see this one here? Just going to shade it in, so that one. If you look at that, that will help you find BC or Y. So that's 15. So if you look at that, that's going to be tan. So tan of 55 equals 15 over Y. So then Y is 15 divided by, I'm going to write it as a fraction because it's easier than division for this situation, is tan 55. Now when I do AC, if you come over here, we're going to need this triangle here, standing up. So if we look at that triangle, you notice they're both right angle triangles because that's the height and that's the floor. So if you look at that triangle, let's just redraw it. You have 40, 15, and Z. So that's going to be tan again. So tan 40 equals 15 over Z. So Z equals 15, and then it's divided by tan 40. So once you've done that, get the triangle that is at the bottom. You get this one that is at the bottom here. And you write on there the things that you found. So you found the X, the Y, and you found the Z, and you want to find the X. So the Y is just there, and the Z is just there. So we know that that is a right angle. So if you now use Pythagoras, X squared equals Z squared plus Y squared. So X squared is what's Z. I'm not going to put in rounded off answers, so I'm going to put in as 15 on tan 40 squared plus 15 on tan 55 squared. And all that's required now is to work that out. So it's going to be 15 over tan 40 squared. And you get 429.9, okay? And then from there, you've just got to square root what your answer is. So square root the answer, which is 20.7. And what units did we have this in? Meters. So it's 20.7 because it's 15 meters. Meters.